Hello, my friends. I wanted to show you what I've been working on. Why I haven't been posting anything recently is because I've been in class a lot this last school year. Um, this last class was a tough one, but really rewarding. And what I want to show you today is what I did for my final project. And it's kind of some really cool stuff that you can do with some math programs that I've been using. So yeah, this was really fun. I got a 4.0 in the class, which I'm really happy about, and so I want to share this with you guys. So first, a little introduction. This class was all about building controls for an airplane, specifically RCAM, which is a simulated model, a hypothetical model of an airplane. And this airplane's used for studies, and so we use this, and all throughout the class we were building a mathematical model of the airplane, and then for the final project we'd use controls to dynamically control it. So I chose for my project to have this airplane stay steady. Um, well, I had the airplane, when I had the trigger on my joystick uh, pulled, it would be under my control with the joystick, but when I let go of the trigger, it would do a barrel or an axial roll and then stay steady and fly by itself and just stay level. Um, so yeah, it's really cool. So yeah, take a look at the video of what I did. We are starting the controller, and I have control. The trigger is depressed, and you can see that I'm flying the plane. I then let go of the controls. It performs an axial roll, and now it will level out. I can then regain the controls by pulling the trigger and letting go, and it'll level out. So pretty cool, huh? So now I'm going to show you how it's done. So this is MATLAB. It's a super powerful program that handles basically any calculation you want to do numerically. So for example, in this command window, I can say, what is 3 plus 3? And it tells me, oh, your answer is 6. Super basic. I can give it variables, like I could say x is equals 3, and now it tells me, oh, x is 3, so I can go x plus 5. And such super basic. It's like a really, really powerful calculator, but it can do some cool stuff. So you can also write programs inside this. They're called scripts. Like over here, I have a script that sets a constant of A, a constant of B, a constant of C, just to show you that it can do it. And then you can have logic in it. So if C is less than 1, blah, blah, blah. So we can run it, and then we see A is 3 down here, B is 6, C is a half, and because C is less than 1, D equals 4. Really basic stuff, but that's kind of what it is. So the really cool thing, especially for controls about MATLAB, is that it has this thing called Simulink built into it. So really nerdy math here. Simulink works with equations, really numerical. It doesn't do symbolic, meaning it can't add an x and a y and keep those as symbols. It has to do everything numerically. So it takes a decimal point estimation down to like 20 decimal places, and it works with it like that. The reason is that in math there's these functions called differential equations, and basically these are equations that are really difficult to solve, and in some cases aren't able to be solved definitely. For example, if we had a line which we could plot as y equals ax plus b, a really common line, we know where the y will equal for any value of x. It's easy, we can plot it out. With some differential equations, you cannot do that. But what you can do is you can estimate it around a specific point. And that is what Simulink does. So our plane is a really, really complex differential equation. And what we have is a simulator to be able to control all that, and it does it all numerically. So for example, in this I have a model that I have built. This is the model of the airplane. It's a little deceiving, This is a function that Simulink uses. Um, and in this function, I am computing a bunch of stuff, and it references another function, which is this, which took all semester or all quarter to build. And what this does is it takes control inputs in. So like I tell it where my aileron is at, where my tail is at, the stabilizer, where my rudder is at, and what my throttles are. And at discrete time steps of like for example, a half second, it will compute the plane's states, which are defined here, which are its angle, its speed, how much it's rotating, that sort of stuff. And it'll keep computing, and it'll just keep going and keep computing, and I'll keep getting inputs. So it loops like that, and I can compute the plane. So this is just a really, really big, long algorithm that all it does is computes what the plane is doing based on inputs. In the video that I showed at the beginning, this is how I know what the plane is doing. The visualizer takes the input from this and shows the plane. So this is all just a big model of the airplane. So that's what this is. So I've got, this is my Simulink model. It takes a joystick controller in. So I tell it, here's what I'm doing with the axes. If I move it, it changes the value. And then I take the trigger. I've got a switch so that if my switch is depressed, I have control. It's doing what I'm doing on the controller. If I let go of the trigger, it switches and an autopilot is controlling it. And then it takes those controls, like if I've tilted it or anything like that, and it puts it into my simulator. And then my simulator tells me, oh, it's this at this time series. And that goes into my visualization, which is what gives us the cool video. So really kind of straightforward through here. Controller in, model simulates everything, and then out to a visualizer so we can see it. And then there's this loop in here, which is what my final project was, which is all an autopilot, which is pretty complex, but really fun. So I take in these different controls, like these are all velocity in X, Y, and Z directions, and it computes just, an airspeed velocity. And then I take in other things and all these different things, and then there's some things I don't want, so I just terminate it. And I won't get too deep into this, more than I already have, but there's this PID controllers you'll see here, and these are in basically every single controller of any automated thing you'll ever experience. Quadcopters have them, everything has a PID controller basically. So I have all these controllers which are controlling everything, and I'm telling it I want my rotational angle about my x-axis, which is the longitude of the plane, to rotate to 2 pi, which means to do a 360 axial turn, and then it's going to stay there. And that's what it does, and that's what you guys saw in the video. So pretty cool stuff. That's what I've been working on. That's why I haven't posted anything else. If you have questions, post them in comments, and I'd be more than happy to answer. I'd be more than happy to put in more videos about this if there's somebody who has questions about my autopilot or really wants to get into it. I'll post a link below to show my final project as it was presented, which is just a 5-minute video, which gets into a bit more of the math behind it. So yeah, I hope you guys enjoyed this. I enjoyed really making this, and I think it was a really fun project that shows the power of mathematical algorithms and models. And it shows kind of what I've been learning in school. So yeah, have a good day, guys.